Okay, adding and subtracting functions, no big deal, and neither is multiplying and dividing functions. Although, of course, the arithmetic gets a little bit harder. So for multiplication, we call the function that's defined to be the product of two functions f times g of x. So fg of x means f of x times g of x. And similarly, f divided by g of x is the function we get by taking f of x and dividing it by g of x. And I want to remind you, this function is only going to be defined where the denominator is not 0, because, of course, we cannot divide by 0. There is no dividing by 0. Okay, so what would this look like in practice? Let's take a look at this in practice. Let's return back to f and g as before. And now let's take a look at g times f. Well, g times f is going to be this times this. And so it's actually going to involve lots and lots and lots of distributing. So let's try it. So I'm going to take this equals 3x plus 2 times the quantity 3x squared plus 5x plus 2. Now, to multiply these two quantities together, I've got to distribute, it's sort of the ultimate in foiling, this term everywhere, and then distribute this 2 everywhere as well. And so when we do that, we're going to get a really long thing. Let's see if we can write it down. I see a 3x times 3x squared. That's going to be a 9x cubed. Then I see the 3x times the 5x. That's plus 15x. Then 3x times 2 is plus 10. Plus 6. 6x. Okay? So that now takes 3x, and I multiplied it by each one of these terms, and I got that. Wait, hold on a second, though. You didn't tell me something. 3x times 5x is 15x, what? X squared. Come on, folks. You're supposed to help me. All right. Now, what happens next? Now we're going to take the 2 and multiply it by each of these terms. And so what do we see? Well, 2 times 3x squared is going to be a plus 6x squared. And then the 2 times the 5x is going to be plus 10x. And then the 2 times the 2 is a 4. And if we combine all this together, what do we see? Well, what we see is 9x cubed, and I'm adding like terms here. So this is going to be plus 21x squared, 15x squared plus 6x squared, plus 6x plus 10x is 16x plus 4. And so, in fact, we see that the product polynomial is actually equal to this long cubic polynomial. How do we get it? We just took this polynomial and we multiplied it by this polynomial, making sure we did the distributing very carefully and correctly. What about if we want to now look at the quotient polynomial? So the polynomial f divided by g of x. Well, here what I'm going to do is take f and divide it by g. So I'm going to look at this polynomial right here. And so I see that this equals 3x squared plus 5x plus 2 divided by 3x plus 2. Let's see if we can simplify this. Can the numerator be factored? 3x and x. Let's put a plus sign both places. And if I put a 2 here and a 1 here, that gives me a 3x squared. Outside terms are 3x. Inside terms are 2x. They add to give 5x. And 2 times 1 is 2. This actually is a correct factorization. And notice that my denominator is exactly the same as one of the factors of my numerator. So I can simplify, and I just see the answer x plus 1. So the quotient function is x plus 1, but there's a caveat. What's the caveat? Remember, it's only going to be defined to equal x plus 1 when the denominator is not 0. So when is the denominator equal to 0? Well, we can go off on the side if you want to, or just on this little sheet of paper right here, and ask ourselves, when is the denominator equal to 0? Well, we can solve that, and we'd see the answer is when x equals negative 2/3. So when x equals negative 2/3, I'd be dividing by 0, and that's not allowed. And so we only have this holding for x not equal to negative 2/3. So we see that when we divide, we have to make sure that we're never dividing by 0. And so, in fact, what we're seeing here is that the quotient exists and equals x plus 1, but only when x is not equal to negative 2/3. Neat stuff.